So question number 1. 2i cap plus 4j cap plus 5k cap. This is a vector. Minus 3i cap minus 6j cap plus 2k cap. This is b vector. Now without paper, without pen, 10 seconds. Find the dot product of these two vectors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Time is over. What is your answer? The answer which you should get should be minus 20. Good, you got it? Very good. You're learning scalar product, dot product. Question number 2. There are two vectors again. 2i cap plus 4j cap plus 4k cap. And there's another vector, 4i cap plus 2j cap minus 4k cap. The question is, find the angle between these two vectors. Without paper, without pen. Let's say 20 seconds. Angle between these two vectors. Dot product. Let's do dot product. If you do the dot product, 8 plus 8 minus 16. Ooh, dot product is equal to 0. So a vector dot b vector is equal to a into b into cos theta. This is equal to 0. Now the magnitude of a vector is not 0. Magnitude of b vector is not 0. That means this term should be 0. Then only dot product of a and b will be 0. Cos theta is 0. That means theta is 90 degrees. So the angle between these two vectors is 90 degrees. These two vectors are perpendicular to each other. Okay? Okay. Suppose a vector is given as 2i cap plus 3j cap minus k cap, and b vector is given as let's see, minus 4i cap minus 6j cap plus lambda k cap. Lambda is a variable that you have to find. Now suppose these two vectors are parallel to each other. Then what is the value of lambda? These two vectors will not always be parallel. There will be one particular value of lambda for which these two vectors will be parallel. You have to find that particular value of lambda. You're working on this? Good. Keep working. Unless you get the value of lambda. Now, we have done it before. If you think from the point of view of direction cosine, or you don't have to think about direction cosine, you just think that what we studied before, when you divide a vector by a number or you divide it by a number, the direction of the vector does not change. Now they have to remain parallel. That means you can divide this vector by any one number. You can divide it with any number, not one number. You can divide it with any number and you will get a vector that will be parallel. Suppose you multiply it by 2. Then you get this as 4i cap plus 6j cap minus 2k cap. Now this vector will have to be parallel to this vector, as we had discussion before. Now if you find the direction cosine of this and you find the direction cosine of this, they are going to be the same. So that proves that these two vectors are parallel. Whether you multiply it by a number or you divide it by the number, direction of the vector does not change by simple multiplication or division. So you can multiply with any number and the vector will be parallel. Now, if they have to be parallel, then you see the first term. You multiply 2 with minus 2 and you got minus 4. And 3 with minus 2, you got minus 6. Then you have to multiply the third term also with minus 2, that which is minus 1. So you multiply minus 1 with minus 2 and you get 2. So lambda should be 2. Straightforward from there. Lambda should be 2. If A vector is parallel to B vector. Now suppose A vector is perpendicular to B vector, then what should be the value of lambda? Perpendicular. Now with perpendicular, it should struck into your mind immediately that their dot product will be 0. And you take advantage of this fact that the dot product of two perpendicular vectors is 0 now and also later in the course. So when two vectors are perpendicular, it should strike into your mind immediately that you have to do somehow the dot product. That can be helpful. It should occur into your mind because A vector, if they are perpendicular, A vector dot B vector will be equal to 0. And it's a good equation that you generate and you can solve a variable from here. So do the dot product, you'll get -8 minus 18 minus lambda. This is equal to 0. Fine. So from here, you would get lambda as -26. Okay. Okay. You're getting the feel of dot product, scalar product. Good. Now suppose A vector this time is 2i cap plus 3j cap minus k cap, and B vector is given as -i cap plus 3j cap plus 4k cap. Now you have to find the component of A vector along B vector. It's a good problem, very conceptual, and it will test your understanding of a vector up till now. You have to find component of A vector along B vector. This one you should really try out honestly on your own. Spend 2 minutes in this and get your answer, please. Okay, now to solve this, suppose you have coordinates like this and you have a vector r vector like this, and this angle is theta. Can you tell me what is the component of r vector along x-axis? Now you will take no time to say it's r cos theta, because you know that when you have to find a component of a vector along a particular direction, then you just have to know the angle of that vector in that with respect to that direction. So if that is theta, the component is r cos theta. Now the magnitude of A here will come out as √14. Now you want a component along B vector, you will get the component along B vector, there's no problem. All you have to find is the angle between A vector and B vector. If suppose that angle is theta, then the component is √14 cos theta, that's it. So we are interested in finding the angle, and dot product helps us to find the angle, because A vector dot B vector is AB cos theta. And magnitude of B vector would be √26. So you know A is √14, you know B is √26, you know A vector dot B vector. You can get cos theta easily from here. So A vector dot B vector, how much would that be? -2, 9, -4. That is 3. So A vector dot B vector is equal to 3. So the either you find cos theta or you get A cos theta from here directly. The component of A vector along B vector is A cos theta, theta being the angle between A vector and B vector. So A cos theta is the component of A vector along B vector, and it comes from here as 3/√26. This is conceptually very important because this is what we will be doing later. If they would have asked component of B vector along A vector, then that would have been B cos theta. That would have been 3/√14. Okay. Okay. Suppose a point is positioned at 3i cap plus 2j cap minus 6k cap. Now it displaces from this initial position to 14i cap plus 13j cap plus 9 k cap. And the force that caused the displacement, it's a uniform force, meaning constant force. That force vector is given as 4 I cap plus j cap plus 3 k cap. Now they are asking how much work this force did in causing this displacement. Now I didn't want to bring it here, but actually we had a little discussion on work, and I actually during the course of explaining you dot product actually told you that I'm so sorry, this force is never a vector, it's a scalar. This work is the scalar. Work is force vector dot displacement vector. So using this simple formula, actually you can do this simple question. There is no issue that you haven't studied the chapter of work. Work is force vector dot displacement vector. Displacement vector is initial position minus final position. That means suppose this is the coordinate and this was your initial vector, initial position vector, and this is your final position vector. And you started from here, you ended up here. What is the displacement? This is the displacement. If you started from here and you ended here. How would you find displacement vector? You'll find displacement vector because you know this is the final displacement vector. So the position you know is 14, 13, 9. And here the position you know. So final position minus initial position, that is going to give you the displacement vector. So displacement vector, D vector, will be final minus initial 11 I cap plus 11 j cap plus 15 k cap. And force vector, work is force vector dot displacement vector. This dot this. That's it. That is the work. That is work. Work is 44 plus 11 plus 45. This adds up to 100. So 100 unit of work has been done. Simple. Okay, let's do the last problem here before you go on to the exercise for dot product. The thing is, if A vector plus B vector, the resultant of this vector, this is perpendicular to A vector minus B vector, then ratio of A by B. You understand, when we don't write this arrow, this is magnitude of A and this is magnitude of B, is your options are 1, 2, 3, 4. Perpendicular. Now did we discuss that when two vectors are perpendicular you have to think about dot product, right? We did. So these are two perpendicular, and two perpendicular vectors, that their dot product is 0. So if they are perpendicular, it should strike in your mind that you have to think about dot product. Dot product can give you some results. Now these two are perpendicular, so their dot product will be 0. So let's do their dot product. A vector plus B vector dot A vector minus B vector. This would be 0 because they are perpendicular. A vector dot A vector will be A square. B vector dot A vector will be BA cos theta, and A vector dot B vector would be minus AB cos theta. B vector dot B vector would be B square. Fine. So this gives us A square is equal to B square. A mod of A is equal to mod of B. So they are asking about the ratio of A and B. That would be 1. Okay. Okay. Now you go to the exercise of a dot product and or scalar product, and you solve all the problems in one go ruthlessly, because they're all easy and you'll be able to do all of them. So you have an opportunity there for your moral boost. And after that, we just have to study one more kind of multiplication, which is called as vector product, in which the product will not be scalar like in this case it will be a vector quantity. So we'll study that, and that will complete the theory of vector.